We're going to take a look at question 1711. This is a simple circuit consisting of a 10-volt source, 2 diodes, and 2 resistors. And so what we're asked to find is the value of all the voltage drops across all the components and the currents in the 2 loops. First of all, we'll notice that in this particular diode, the cathode is attached to the positive end of the battery. That means that this diode over here is in fact reverse biased. That means it's not passing any current, and in fact we could safely remove it from the circuit and the circuit wouldn't even know it was gone. Looking at the second loop, however, it's the anode which is attached to the positive end of the battery, and so we know that this diode is forward biased. This battery at 10 volts has certainly got enough voltage to be able to completely forward bias this diode at 0.7 volts. So now we can begin recording some of these values. For example, we start off by saying the voltage across diode 1 is equal to 10 volts. And the reason for that is because since there's no current flowing in this loop, we had a voltmeter at this point, it would simply measure the potential across the source. And since the diode is reverse biased, there's no current in R1, and so we can safely say that the voltage across R1 is equal to 0, and as already mentioned, the current in loop 1 is equal to 0 milliamps. Looking at the second loop, we can say since the diode D2 is forward biased, the voltage across it is equal to 0.7 volts. To find the voltage across R2, we simply apply Kirchhoff's voltage law, which simply states that the sum of all the voltages in a loop equals to 0. So we just walk around the loop and see what we get. Starting off, let's say here, we see minus 10 volts plus the voltage across R2 plus the voltage across the diode, which you've already seen is 0.7 volts. And that all equals 0. From this we can see right off the bat that the voltage across R2, this should be R2, is equal to 9.3 volts. And because of Ohm's law, and the fact that we know both this resistance and the voltage across the resistance, we can calculate the current in that loop. Current in loop 2 is equal to the voltage across the resistance, 9.3 volts, divided by the resistance itself, 1.8 k ohms, and that equals 5.167 milliamps. And now we know all of the voltages and the currents in that entire circuit.